infrastructure. And therefore you need, again, a water level that is not highly variable. So the purpose of the barrage is to stabilize the upstream water level. The purpose of the barrage could also be to stabilize the riverbed, because if you want to take water, you are concerned by erosion, by changes in the riverbed elevation. And therefore, the purpose of the barrage is also to create a fixed point over the riverbed to prevent erosion and to prevent deposition of bed load, or if it occurs, to give you the opportunities to clean it, to remove it. So the purpose of the barrage is then twofold. First of all, stabilize the water level upstream, but also to stabilize the riverbed. Keep in mind that there might be barrages that you see over rivers, small barrages, low-head barrages, that are not meant for diversion, because indeed the barrage is also finalized to stabilize the riverbed. In some cases, then, you can see barrages that are built for the only purpose of stabilizing the riverbed. And in this case, however, they are, at least in Italian, not called barrages, but they are called check dams. I want to show you a couple of pictures. And I make reference to the literature in English. So, if you Google for river barrage, you get a Wikipedia page. Which shows some pictures. And let me look at some of them. Let me look at the images, sorry. Because these pictures are not very representative. The first one maybe, but okay, so let me take this one is fine, but I'm looking for some more. For instance, this one is looks like a barrage for water diversion. Yeah. Or when I look for, just a second, it's always slow and okay, let's look at this one, which is more representative. This is a barrage, low-head barrage. I'm not sure it is meant for water diversion, or in this case it could be meant for, I'm sorry that it's not very clear, it could be meant for stabilizing the upstream water level for the purpose of navigation, because there are also many cases in which the barrages are built for ensure navigation, and in this case they are meant to only stabilize the upstream water level. But in any case, let's now look for check dams. So you can see the difference. And let me look at the images. And there is a nice image here. But let me see if there is. These are check dams, and which are used to stabilize the riverbed. And there was an image here, which is representative of Wikimedia Commons. And this is a check dam. And you see that here there is no diversion, but there is, the purpose is to stabilize the riverbed to avoid erosion. You see that there is the central part of the transversal structure that is placed at a lower level with respect to the lateral parts, with respect to the parts that are located close to the hill slope. The reason why there is this lower part is that we want to concentrate, we want to keep the river flow far from the hill slopes to avoid erosion at the foot of the hill slopes. This central part that is lower than the remaining part of the structure in Italian is called gavetta. I'm not sure that there is an analogous term in English. So, but I want to give you the term in Italian because it is important also that you know the terms that are used in Italy. So in Italy, when we say gavetta, we just mean this, and it's clear for all the engineers working on rivers. And these parts that connect the central part to the part that is close to the hill slope, these parts are called wings, ali in Italian, and their slope is about 100%, 45 degrees. And the width of the central part is more or less half of the total width of the structure, maybe more than half. Usually this central part is designed in order to allow the flood flow to be fully contained into the central part, the flood flow for a given frequency of occurrence. I'm telling you these details because if we look at the main spillway of a river barrage for water diversion, it is very similar to this structure, very similar. But it is also equipped with spillways to allow for the water diversion, So, as I said, you may see different type of river barrages. When we talk about river barrage, we usually imply the presence of a water diversion structure. And again, when we have structures that are only finalized to stabilize the riverbed, we use the term check dams. In any case, these are all low-bed structures. And in fact, there is, and we need to make a difference between river barrages and dams. We need to make a difference because you can understand very easily that a dam is a more delicate structure with respect to a barrage. It's a more important structure for many reasons. It's more costly, it's more dangerous, it needs to be designed and monitored very carefully. I mean, also barrages need to be designed carefully, but of course, the rigor that you have to adopt and especially the number of checks that you have to make when designing a dam is much more complicated with respect to the procedures that you follow to design a river barrage. So we need to make a difference. We need to be able to clearly distinguish when we are talking about a barrage and when we are talking about a dam, because also a dam is often conceived for water diversion. But there is a striking difference, and the striking difference is the amount of storage. A dam is intended to regulate the river flow, and therefore it induces an upstream storage that is much more relevant and much more dangerous in case of failure. A river barrage, if it fails, usually doesn't induce risk for humans. So given that we need to set a quantitative criteria to distinguish between barrages and dams, let's look at what criteria is used in Italy. In Italy we set two constraints in order a barrage not to be classified as a dam. So a barrage shouldn't exceed 15 meters of height and shouldn't induce an upstream storage greater than 1 million cubic meters. So again, two constraints, 15 meters height and not upstream storage for more of 1 million cubic meters. If one of these two constraints is violated, the barrage is classified as a dam, and therefore the design must satisfy more strict criteria. And the structure should be monitored by a governmental body that, of course, checks what are the safety conditions of dams. These two criteria apply in Italy, but similar criteria apply in several other countries. Now, you could ask me, how do you measure the height of a structure? The law is clear. If you have a barrage like this, with the foundation, and this is the riverbed, the undisturbed riverbed, then you measure the height from the top of the structure to the base, to the lower level of the foundations. This is the height. So you take the highest point that can be surmounted by water. So the highest point that can be surmounted by water, and the lowest level of the foundations. And how do you measure storage? How do you measure storage? Storage is measured by considering a geometrical volume that is identified by the geometry of the undisturbed riverbed and the upper part, let's say the upper, let me put it at a lower level, the upper regulation level. The upper regulation level is defined during the design. You get a maximum level that you can use for regulation. Of course, this level can be exceeded if you get a flood, if you get something that it's not part of the daily use, of the day-to-day use of the structure. But when you design, you set up in working conditions what is the higher level, and therefore from the higher level to the geometry of the undisturbed riverbed, you compute the volume of the storage. So these two criteria allows us to clearly identify if we are talking about a barrage and we are talking about a dam. You may say, yes, but when I'm working in the border is something that is not easy to define. But usually, let me say that when we talk about river barrages, we are very far from these two conditions. And usually we talk about structures that are 5-7 meters high, and the storage is much less than 1 million cubic meters. Okay, let's have a break.